Hi, and thanks for having me. As you can probably see, I'm a bit of an exotic guy here because, well, all of the projects I have to talk about today are all come from the Apache Software Foundation. But I'm really happy to be here because I know that both the Eclipse Foundation and the Apache Software Foundation, we have so many awesome projects, and working together a bit more will make such an impact. So I'm really hoping on getting a few of you guys on board with what awesome stuff we're working on, and maybe let's play together. First of all, this presentation is made by a pretty new project at Apache called Apache Training, and we're trying to sort of like spread knowledge of our projects amongst the other projects and with the world by providing a central place where we can put our training material. And in general, it's just like coding. Some ASCII doc compiled to a presentation via Maven, and on this site, we'll always also have the presentation material I'm showing you here available in a week or two. So what am I going to be talking about? Well, I'm going to be sketching out a few typical data acquisition scenarios I've come across over the last 8 years, where I've been completely working for industrial use cases. And especially go into the problems I run into. Because even if you go to the industrial fairs where they all talk about all of their awesome success, well, actually, there's a lot of failure in that. And I'm going to go into which problems I've typically seen all over the planet, and how we can, especially how we can solve them with various Apache projects that we have. In the end, going to wrap it up with a sort of like a big picture that I have of how we could make data acquisition and industrial automation awesome. Yeah, so let's start. So we've got some typical scenarios here. You can see I've tried to sort of like put all of the different scenarios I came across into one big picture. So right over there, you can see some narrowband devices, usually wind parks, solar parks, some distributed equipment where it's usually not feasible to have, let's say, a wired internet connection. So usually narrowband internet is used, LoRaWAN, Sigfox, you name them. Then we have more and more data collection in mobile devices, sort of like trucks, trains, even cars. I mean, with this whole Eclipse software-defined vehicle, well, there's lots and lots of data showing up in these cars. And so if we want to do something sensible with it, how do we store that? How do we get the data back to where we can process it? Moving into the shop, to the manufacturing shop floors, well, we have different types of PLCs, different types of industrial equipment. It's hard to communicate with them. Yeah, so let's say, yeah, we've got this typical tree-like network structure usually, loads and loads and loads of devices. So I think one of the last factories I went to, I think they had definitely a 5-digit number of network devices on their shop floor networks. Yeah, so I put some little exclamation marks and little bubbles to typical problems that I've seen all over the place. We'll go into all of them on the following slides. I just wanted to show you sort of like where, in general, I see pictures. And I try to sort of like show this whole bandwidth problem with the width of my lines that I used there. So you can see in some places the lines going into a device are too big. Well, that should indicate an overload situation. So let's start with accessibility problems. So as I mentioned, if you go out into a shop floor of any manufacturer, you will find loads and loads and loads of different types of devices. Most of them are even connectable via Ethernet connections. But the one thing they will all have in common is they will all be speaking different languages. So we've got loads of devices out there. They're all speaking different protocols. They're all using different types of settings. And for all of this, there was actually no typical open source way to access data on these systems. Another problem is, more and more data sort of like overloading the networks. This is, for example, I think it was 8 years ago, OPC was sort of like announced. And everybody, if you went to the SPS in Nuremberg, you were probably told that OPC is solving all of our problems. But admittedly, it started creating a new type of problem. And yeah, so in order to tackle this, I had the luck at my previous employer to actually be able to start an open source project. And that was Apache PLC4X. It was my goal at that time to sort of like do what JDBC did for relational databases, but transfer that to the domain of the industrial equipment. So it's a universal protocol adapter where we implement the native communication protocols of the various industrial protocols, currently sort of around 19 that we implement. But to make all of this information available and accessible with a shared API, because that is the one thing we currently have nowhere. A shared API to communicate with all different types of systems. Also, PLC4X, I knew, well, obviously, if you had asked me, I would probably do everything with Java, but I know that in the industry, Java is not quite so dominant as it is, let's say, in the IT world. So I knew we need to make PLC4X available in other languages too. And that's also why it has an X at the end. Otherwise, it would have been PLC4J, but we wanted it to support multiple programming languages. Currently, we support Java, Go, C, C#, Python, and we even got a pull request in, been dangling around a bit for a while for implementing our drivers in Rust. So you guys probably, being at the Eclipse Foundation, the home of Eclipse Milo, and the home of the Sparkplug B working group, why not use that? Doesn't that solve all of our problems? And as I mentioned before, well, not really. It does sort of solve this Babylonian problem of different types of machinery from different vendors speaking not the same language. It solves that problem, but it adds another problem. So if you can see up there, this is a little Wireshark recording I did for just reading a simple Boolean value. And just ignore all the hex gibberish down there. The interesting part is the length. So we're sending 217 bytes over the wire just to read one Boolean value. Another example, this is MQTT. And this is sort of like vanilla MQTT. This is not Sparkplug B. That would add quite a bit more, not as bad as OPC, but it would add more volume to the whole thing. But you can see here, 106 bytes for just transferring one bit. Now, if we have a look at Modbus TCP, this is sort of like one of the most simple industrial protocols that we support. And here you can see, well, it's 63 bytes. Also for transferring just one bit. But I think you can imagine if you're transferring loads and loads and loads of different data points on your network because you want to do some machine learning, predictive maintenance, whatever. So you're reading lots and lots and lots of data. I think being able to sort of like send a data packet in a quarter of the size, I think you can all imagine that you would, with OPC you very soon reach the capability that your network infrastructure is able to handle. And that has actually been something I've come across very, very often. So by using the native protocols, so it doesn't matter which PLC type you have, which vendor you have, every vendor has one native protocol that it sort of like natively supports. For Siemens, it's the S7. For Beckhoff, it's the ADS. I think for Allen Bradley, it's Logix. I think for Schneider, it's UMass. But these are the protocols. These devices are made to speak. And they are coming from the industrial automation area. They know how to deal with constrained devices. They know how to preserve network bandwidth. So these all have very small packet sizes. They all reduce the load on the network. They also reduce the load on the hardware because being able to speak Sparkplug B or OPC UA, that adds a little application server to your PLC. So it's a lot more work that device has to do. And if you ask it a lot of questions, your PLC will get really, really grumpy really, really fast. Have you guys seen these magazines lying around, this IT and Production magazine? I think one of the cover stories is one company complaining about how OPC UA and all of these problems actually hindering them from doing their digital transformation. The money, I think he's complaining about the money for the license costs, but also the performance. So it's not me making up this stuff. So, assuming we've got this whole communication problem solved, let's go to the next layer. So I already mentioned that we're very quickly saturating the capabilities of the network infrastructure. As you can see over here, I have really seen many 10 Mbit and 100 Mbit hubs being used in industrial environments. So you really need to be careful with how much data you transfer. And others, if I've just got too many devices and I want to pump up the data to the next higher level, well, it might be just too much for the network to handle. I guess my favorite one is always the one too much load for the internet connection, because the one thing I've always seen is when a company tries to go full digital, well, they start, now we want all telemetry from all of our production machinery. We want all of that in the cloud, and we want to do awesome stuff with it. But you got to keep in mind, your internet connection needs to be big enough to transport all of that data. And I haven't seen a single company, and it doesn't matter where they were, where this internet connection was actually big enough for them to transfer all of it. So they usually settled with just sending every 10th packet or something like that, which sort of is stupid because you lose a lot of data. Another thing, everyone who's so when I was sitting in the train, just driving from Darmstadt to here, I think there were 3 places where my mobile phone didn't have any internet connection. So if we're talking about connected cars, well, I would call them partially connected cars if they drive in Germany. So we have to deal with sort of like, what do we do when we're not connected? How do we locally store data? And that's where Apache TsFile comes in. TsFile is a pretty new project at the Apache Software Foundation, but the code isn't that new to Apache, because prior to the to TsFile being created, TsFile was actually part of Apache IoTDB. It was sort of like the storage technology used by IoTDB, and IoTDB itself was the query engine on top. We split that up because we wanted to release TsFile also in other languages, because we think the storage technology is very valuable even without the query engine on top. Apache TsFile is sort of like, I think it's pretty often compared with Parquet, but a lot more efficient and a lot more optimized for storing time series data. It allows storing aggregated data, highly compressed data, and highly compressed, we're talking about compression down to now 10% of the original size if you want lossless data storage, and we can even go down to 1% of the original size if you accept lossy. And I mean, lossy, it always sounds like, oh, why should I give up on so much valuable information? I mean, in IoT, we're talking about temperatures, for example, yeah? And I don't really care if I get all the 20 digits after the dot right, or if it's just 5. If it's 21 degrees, it's nice. And if it's 16 degrees in my office, it's cold. So sometimes, really, this lossy storage isn't actually really a bad thing. We're working on, I think currently TsFile is available in Java, in Go, in C or C++. But the community is always working on supporting in new languages. But how does Apache TsFile help? Well, we can actually start collecting data on the devices. So assuming PLCs, so what I've seen so far was you've got this device and it has some information stored in it and you want to know this information. So you keep on polling this device every 200 milliseconds. What's the value? What's the value? What's the value? And because you need to approximate the data that's on the device, off the device. By starting to write the data on the device, we can switch from a pull to a push, which drastically reduces the traffic and the load on all of the systems involved. And you even get a bonus, cyclist synchronous data. I guess those of you in the audience who don't know what that is, the thing is, if I read 1,000 data points from a PLC, one would assume that all of these data points come from the same time of execution that I sent the request. But that's not how PLCs work. So they will start replying and maybe just finish to 300 data points. And then sort of like the cycle's over, they send off or they just pause preparing the response. The CPU continues because it can't stop, because otherwise, well, the knife won't stop or something just won't work. So actually having cycle synchronous data is really a problem. By writing it on the device, we would get that for free. So we would be implementing sort of like libraries for the various program OT environments, sort of like for TIA Portal, a library you pull in. For CodeSys, we would be providing libraries where you just, so like in your PLC program, say, now write this value and this value and this value, and it would be stored with a timestamp. And as soon as, let's say, the item leaves the machine, then we send off this TsFile data in one MQTT packet, and we're done. Another thing is we can start utilizing the bandwidth of these narrowband internet, LoRaWAN, Sigfox, to the maximum, because one of the problems is you are very limited in the size of packets that you're allowed to send, but also on the amount or the interval in which these packets are sent. So it would be really nice if we could sort of like fill up our TsFile packet till we utilize the maximum capability of that transport medium. And as soon as that's full, we send it over the wire and we start filling a new bucket. This way, we can transfer as much as possible data utilizing these narrowband internet connections to the maximum. And, well, maybe the case for the software-defined vehicle. Well, if you're just sort of like stuck somewhere between Darmstadt and Mainz, and your telemetry sort of like can't go into the cloud, well, you just write it into TS files, and as soon as you come out of the no connection tunnel, it's uploaded. And because it's so highly efficient with compressing data, you don't have big requirements. So I started logging all of the data my KNX network at home is producing. So I got this Raspberry Pi 5, and I thought, oh, well, I want to log for a few years, so maybe I'll get a 1 terabyte SD card. The thing was, 3 months of logging all of the data, and I've got an EV, a solar power grid, and a geothermal heating system, so they produce lots and lots and lots of data points. And after 3 months, I was at 120 megabytes, so I guess probably my 1 terabyte SD card will will be enough for the next 500 years. So I think this gives you a little impression on how efficiently TsFile can store this data. Another problem, data volume, and especially the granularity. Let's start at the bottom. So one thing I've seen quite often is, sort of like you've got your production machinery, and it's controlled by an MES system, and it's working nicely, and then there's this new OT dashboard somebody, some department wanted, and they start collecting additional data. So they're asking the same PLC, the same questions again. And then there's this another overall equipment efficiency calculator that also needs to query data from the PLC. So it's asking the PLC again. And I've seen it quite often that the sheer amount of different clients asking the PLC the same questions makes the PLC shut down in the end. So in the end, your production line is flat, it's doing nothing, just because you've been asking the PLC too many questions, and you've been asking the same questions over and over again. Another thing is, so if you're sort of like collecting loads of data on the shop floor, it's a bit unfortunate. I think you can't see the light gray boxes on there, right? I drew so nice light gray boxes. Assume down here the 3 IoT devices and the gateway, that is sort of like one line. And if we're doing a lot of data collection there in order to do decisions on the gateway, usually there's all data being collected on the line level is replicated to the next higher level, even if it's not really needed. So you very easily overload the network infrastructure between the line and the factory level. Because if all of this sort of like, it's like a tsunami of data coming up. Also assuming for some miracle reason you have the ability to pump all of that data into the cloud. Well, the thing is, cloud storage is not for free. So you're actually storing loads and loads and loads of data that you will probably never need because, I mean, on cloud level, usually I've seen many dashboards implemented that actually needs data on a granularity of, well, a few minutes or a few hours or something like that. They don't care about milliseconds on that level. So you're actually just pumping way too much data upstream. The reason for that is I don't know a single system except the one I'm presenting, that allows this sort of like reduction of data. And that's where Apache IoTDB comes in. Apache IoTDB is able to sort of like act as a central data hub. So what you can do with Apache IoTDB is, well, you start collecting data and you pump the data you're collecting into IoTDB. Now, instead of having each app ask the hardware, what's the value, what's the value? Well, you just subscribe to IoTDB, and you can even do streaming queries. So you can do, oh, well, please inform me as soon as there's new data there. So you get a callback from the database. So you can write your, let's say, microservices a lot simpler to react to changes in data. IoTDB does an exceptionally good job with aggregation. So in the industry, I've usually seen so-called tag historians based on some relational databases. I think I've seen MS SQL or Oracle being used. But the types of queries used in industrial automation are usually time series data. And so asking an MS SQL server to please aggregate the last 3 months of this 100 millisecond granularity signal and aggregate those into windows of 1 hour and just give me the average of every window, well, I think with that you can kill any Oracle server or MS SQL server or just relational database server. You just can kill all of them, but it's what IoTDB actually does best. You can also do automatic replication. So as soon as data gets inserted on the line level, it automatically can get replicated to the next higher level. But the cool thing is you can also apply aggregation to that. So if you collect data in a millisecond level on the shop floor line level, well, you can sort of like say, I'm just interested in sort of like 5-minute averages being replicated to the next higher level. And that's what IoTDB does out of the box. Yeah, one thing I didn't mention, so this subscribing and using one central data pool as sort of like the single source of truth and all applications sort of like reading and writing to that is what is generally referred to as sort of like this unified namespace architecture. IoTDB sort of like out of the box sort of like allows to start working this way. One of the really cool things is, so if you're working on a project and you think it's really awesome, it's really cool if you sort of like actually have it compete against its competitors. And I mean, I'm one of the guys, if I see a benchmark, if I'm looking for test results for a product, I never click on the test results of the vendor offering the product because, well, nobody trusts the benchmark that the vendor itself did. So what we did was we had the two benchmarks that we could find. One is from a German company called BenchAnt. We had them analyze the performance of IoTDB, and the TPC Foundation with their TPCX IoT benchmark. Those of you who don't know the TPC Foundation, this foundation is so old, their web system today is still sort of like, it really feels like being back in the 90s. So the TPC Foundation, I think, was created to be able to have comparisons between relational databases, and I guess from times in the 90s. And the TPCX IoT benchmark is a pretty new one that targets industrial IoT use cases. And the thing is, it doesn't matter which benchmark we're in, we always come out first place. So here's maybe just a short example. It doesn't matter which performance metric in the end you search by or sort by, IoTDB always comes out first place. And what I found even more impressive was the results of the TPCX IoT benchmark. If you just have a look, so the first two lines, I should mention TimecoDB is sort of like the commercial offering of Timeco for IoTDB. It's sort of like if a company wants to use Apache IoTDB, but they want commercial support and stuff like that, that's when they buy TimecoDB. And as Timeco is a member of the TPC Foundation, we had to list the results of TimecoDB and not IoTDB, but it's effectively, for the parts of this benchmark, it's actually pretty much the same thing. But what you can see is sort of like if you just take the first place and the third place, that's sort of like double the performance with 1/3 of the cost. And as this is sort of like the commercial offering of IoTDB, well, I assume that if you use the free version, the costs will significantly go down. So, putting it all together, and I think I'm sort of on still good on time. So, in order to talk to devices that I don't have any influence on, or on which I can't run IoTDB directly, TsFile directly, or whatever, use Apache PLC4X for accessing this data. Run PLC4X on some gateways that sort of like communicate with them, collect the data, and store it on gateways that run IoTDB. Install TS files on devices that allow it. I'm really looking forward to sort of like writing, let's say, a CodeSys or a TIA portal library to sort of like start collecting TsFile data on the device. With that, you can sort of like really reduce the volume of data on your networks, and you can reduce the load. Start using IoTDB as sort of like a central place of trust, or the single place of information. Start this unified namespace conversion. I think you can see up there the two apps on the top level, they in the first ones they sort of like they talked to the cloud. Do your processing locally inside the company-wide IoTDB server. And with this, you'll have a lot of less problems. So what's needed for that? So what's not quite yet existing? Well, for TsFiles, we've got the libraries in C and Java. What we need to do is sort of like build these libraries that I mentioned for CodeSys, for TwinCat, for TIA Portal. I chose MQTT as a proposed protocol because all of the PLCs I've come across, they already have libraries for sending MQTT. And especially the network administrators, they know how to configure the network switches to handle MQTT traffic. Build gateways to store data locally in TsFiles. Yeah, I think I already said a few of the things on that. Set up some servers based on Apache IoTDB. Use this sort of like use these features of replicating to higher levels. But for example, as I said, maybe on the line level you need millisecond granularity because you need to instantly sort of like interact with the machine. But you don't need that on the next higher level. So just aggregate data and shove it up. With IoTDB, you can, for example, have a retention of just 1 day on the line level, but you have one of a year or so on the next higher level, and you can, so like going up into the cloud, you can also play with the retention period. So you can, in the cloud, you can just store everything forever if you want to. Yeah, so I don't want to be taking the next speaker too much of his time. Thanks for listening. I hope I could sort of like get one or two of you interested. If you want to join in, I've listed up at Apache, everything happens via mailing lists. So these are the mailing lists for the projects I was talking about. If you want to quickly contact me to discuss some idea or whatever, or just tell me how shitty my talk was, well, that's the QR code for my LinkedIn profile, so I'm happy to connect with you guys. Yeah, so thanks for listening. And do we have any questions?
I'm audible? Yeah, okay. How much effort would it be to do a PLC library of TsFiles?
Well, I would assume that it differs very greatly which system we're talking about. I would assume that for TIA Portal, it's probably going to be more challenging than for CodeSys, because getting information usually is a bit trickier. But I don't think it's that difficult.
Yeah, I would also start with CodeSys. So, okay. I think the hard part is configuring what data to send, or?
Yeah. Yeah, well, I guess that is the thing, the automation engineer who writes the PLC program. I think that person is actually the best person to know, oh, so now I've sort of like cut, and now there was this pressure value or whatever. I want to log that away. So it will definitely be the person knowing his process that will be in charge of deciding what's to be logged when.
So it would be more like, so I have something to log, I would call a method of the...
Yeah. Yeah, I think anything else wouldn't really make sense. So logging all of the parameters all the time, that doesn't make any sense. But I know that it would be awesome if sort of like the automation engineer sort of like, okay, now I've done this value is interesting for that. Then I'm doing another bit of the process, and for that, this value is interesting. So you'd always get the most interesting data out.
Yeah, I think that would be really the hard part, to get that into a PLC.
Yeah. Well, with structured text, it's a lot easier. If you want it in these stupid ladder logic diagrams, oh gee, I think that's going to be a pain.
It does not matter too much. There's a bigger problem behind that. It's the execution model of the PLC. But that's something for a different. I'm not sure I'm boring someone. So, but we could discuss that maybe. That's an interesting thing.
Any other questions? Okay. Well then, thanks. Oh, okay. One more.
You were talking a lot on the data acquisition side. What about like sending data to the devices and so on, like, or sending method calls and so on? So how would it fit to this architecture?
Well, that's what PLC4X would then be used for. But I think there are also so IoTDB also is able to sort of like send MQTT messages or send stuff. So that's sort of like that's sort of like just a configuration detail. I think that problem is even solved already.
Okay, yeah.
Any other? Well, then Toddy and I say thank you for having us. It was a pleasure being at this Eclipse event, and I really hope that we'll be sort of like joining some forces. We've got so much ideas how we could sort of like bring our projects together, and I'd really be happy to see some of that happen. And so, thank you.